Okay, so I'm going to go back over example 4 since we were running short on time in class today. So the first thing you want to get out of a circle is its center. So here the center is going to be at 0, 0 because nothing is subtracted or added from x or y. There's no h or k. So the center is at 0, 0. The radius is going to be 5. Since r squared is 25, that makes the radius 5. The point of tangency is given in the problem. It's going to be 3, 4. So the next thing we want to do is just sketch a quick picture so we have an idea of what's going on. The center is at 0, 0. It's going to go through the point 3, 4, and this is going to be our circle. Now that was what we did through example 2, but now we're adding on to that. What I really want is the equation of this tangent line. Okay, so the first thing we're going to do is we're going to find the slope of the radius at the given point. So here I went over 3 and up 4. So rise over run tells me that I rose up 4 and I ran over 3. Now that theorem in section 1 tells us that the radius and the tangent line are perpendicular, and we know that perpendicular means that I'm going to have opposite reciprocal slopes. So if the equation of the slope of the radius is 4 over 3, then the slope of the tangent line is going to be, you're going to flip that over and change the sign. So from 4/3 to -3/4. So I know two things about this line. I know his slope is -3/4, and I know he goes through the point 3, 4. So I'm going to use point slope formula to do the rest. So the formula, remember, is y minus y1 equals m times x minus x1. The x and the y are going to stay in the formula, and y1 and x1 are going to be what you replace. So y minus, the y value is 4, is equal to m, the slope is -3/4, x minus the x value is 3. Okay, we're going to distribute. Y minus 4 is equal to -3/4 x plus 9/4. And then the last job is to move the 4 to the other side. Now this is a fraction and this is not, so I'm going to get a common denominator. Y is equal to -3/4 plus 9/4 plus 16/4, because 4 times 4 is 16. I'm running out of room. Y is equal to -3/4 x plus 25 over 4. Sorry, I got a little cramped there. Okay, so that's writing the equation of a tangent line. Now it's a lot of steps at first, but the nice thing is that it's always the same steps every time. So you identify the center and the radius and your point of tangency. You plot a quick graph so that you can get a good idea of what's going on. You find the slope of the radius using rise over run from your center to your point of tangency. Opposite reciprocal for your slope of your tangent line. Then you use point slope form using the slope that you found, the opposite reciprocal slope, and the given point of tangency, and solve for y. Okay, I would pause this video for a second and try to do B on your own, and then come back and see if you did it the same. Okay, here we go. So here the center of the circle is at 1, -2. Remember, the center is opposite signs because the minus belongs to the formula, not the number. So 1, -2 is the center, and the radius is 5. From 25 is r squared, so it goes backwards. My point of tangency is 5, -5. So let's graph a quick sketch to see what's going on. 1, -2, and 5, -5. Okay, so the first thing to do is find the slope of your radius. So from here, I went from -2 to -5, so that is down 3. I went from 1 to 5, so that is over 4. So the slope of my radius is down 3 over 4, meaning the slope of my tangent line is going to be opposite reciprocal. It's going to be 4/3. And if you look at your sketch, while not exact, you can tell it's going to have a positive, fairly steep slope, so that's good. Then I'm going to use point slope form. So with my new slope and with a point of tangent C. So y plus 5 is equal to 4/3 x minus 5. Y plus 5 is equal to 4/3 x minus 20/3. Going to move the 5 over, and I'm going to do a common denominator, 15/3. That cancels. Y is equal to 4/3 x minus 35/3. There's the equation of your tangent line.